Hello everyone, welcome to new class. Today's class is about the Boolean algebra. Boolean algebra is a system of mathematical logic. Any complex logic statement can be expressed by a Boolean function. The Boolean algebra is governed by certain well-developed rules and laws. In the applications of Boolean algebra, we use capital letters to represent the variables. Any single variable or a function of the variables can have a value of either 0 or 1. The Boolean algebra differs from both the ordinary algebra and the binary number system. In Boolean algebra, a plus a equal to a and a dot a equal to a. Because the variable a has only a logical value. It doesn't have any numerical significance. But in ordinary algebra, a plus a is equal to 2a and a dot a is equal to a square. This is in ordinary algebra. Because the variable a has a numerical value here. And also in Boolean algebra, 1 plus 1 is equal to 1. But in binary number system, 1 plus 1 is equal to 1, 0. And that in ordinary algebra, 1 plus 1 is equal to 2. So that is the difference between Boolean algebra, binary and ordinary algebra. A variable or a function of variables in Boolean algebra can assume only two values, that is either a 0 or a 1. Whereas the variables or functions in ordinary algebra can assume an infinite number of values. Thus in Boolean algebra, if a is equal to 1, then a is not equal to 0. And if a is equal to 0, then we can say a not is equal to 1. Next is logic operations. The AND, OR and NOT are the basic three operations or functions that are performed in Boolean algebra. AND operation. The AND operation in Boolean algebra is similar to multiplication in ordinary algebra. OR operation. The OR operation in Boolean algebra is similar to addition in ordinary algebra. NOT operation. The NOT operation in Boolean algebra is nothing but the complementation or inversion. That is negation as performed by the NOT gate. In addition, there are some derived operations such as NAND, NOR, XOR and XNOR that are also performed in Boolean algebra. NAND operation. The NAND operation in Boolean algebra is equivalent to AND operation plus NOT operation. AND plus NOT. NOR operation. The NOR operation in Boolean algebra is equivalent to OR operation plus NOT operation. XOR and XNOR. The XOR and XNOR operations on variables A and B in Boolean algebra are denoted by A XOR B equal to A B bar plus A bar B, and XNOR is A XNOR B equals A B plus A bar B bar. Next is axioms and laws of Boolean algebra. Axioms of Boolean algebra are a set of logical expressions that we accept without proof and upon which we can build a set of useful theorems. Axiom 1 is 0.0 equal to 0. Axiom 2 0.1 equal to 0. Next one 1.0 equal to 0. Next is 1.1 equal to 1. 0 plus 0 equal to 0. 0 plus 1 equal to 1. 1 plus 0 equal to 1. Then 1 plus 1 is equal to 1. 1 bar equal to 0. 0 bar equal to 1. Next is laws of Boolean algebra. First one is complementation loss. The term complement simply means to invert. That is to change zeros to ones and ones to zeros. The complementation laws are 0 bar equal to 1, 1 bar equal to 0. If A is equal to 0, then A bar equal to 1. And if A equal to 1, then A bar equal to 0. And also A double bar equal to A. So these are the complementation laws. Next is AND laws. AND laws are A dot 0 equal to 0, A dot 1 equal to A dot A equal to A dot A bar equal to 0. The OR laws are A plus 0 equal to A plus 1 equal to 1, A plus A equal to A plus A bar equal to 1. Next is commutative law. Commutative laws allow change in position of AND or variables. The two commutative laws are A plus B equal to B plus A and A dot B equal to B dot A. Next is associative laws. Associative laws allow grouping of variables. First one is A plus B plus C equal to A plus B plus C. That is A or B ORed with C is same as A ORed with B or C. Next is A dot B into C equal to A into B dot C. That is A and B ANDed with C is same as A ANDed with B and C. So this is associative laws. Next is distributive laws. The distributive laws allow factoring or multiplying out of expressions. That is A into B plus C equal to AB plus AC. This law states that ORing of several variables and ANDing the result with a single variable is equivalent to ANDing that single variable with each of the several variables and then ORing the products. Next is A plus B into C equal to A plus B into A plus C. This law states that ANDing of several variables and ORing the result with a single variable is equivalent to ORing that single variable with each of the several variables and then ANDing the sums. Next is a plus a bar b equal to a plus b. This law states that ORing of a variable with the AND of the complement of that variable with another variable is equal to ORing of the two variables. Next is idempotence loss. That is a dot a equal to a and a plus a equal to a. Idempotence means the same value. That is ANDing of a variable with itself is equal to that variable only. Also, ORing of a variable with itself is equal to that variable only. Next is complementation loss or negation loss. First one is a dot a bar equal to 0. That is a variable ANDed with its complement is always equal to 0. Also a plus a bar is equal to 1. That is a variable ORed with its complement is always equal to 1. Next is double negation law. This law states that the double negation of a variable is equal to the variable itself. That is a double bar is equal to a. Next is identity loss. That is a dot 1 equal to a. That is a variable ANDed with 1 is equal to the variable itself. And a plus 1 is equal to 1. That is a variable ORed with 1 is equal to 1. Next is null loss. A dot 0 is equal to 0. That is a variable ANDed with 0 is always equal to 0. And a plus 0 is equal to a means a variable ORed with 0 is equal to the variable itself. Next is absorption loss. That is a plus a dot b equal to a. That is ORing of a variable with the AND of that variable and another variable is equal to that variable itself. That is ORing of a variable with the AND of that variable and another variable is equal to that variable itself. And also a into a plus b equal to a. That is ANDing of a variable with the OR of that variable and another variable is equal to that variable itself. Thank you for watching the class. If you like the classes, please like, share with your friends and subscribe my channel.